Hey guys, tonight we're lying beneath a wide, ink-soft sky. So still, so quiet, it feels like the world is holding its breath. But it isn't. If you listen just a little differently, not with your ears, but with the space behind your ears, you'll feel it. A shimmer, a tremble, a gentle pressure in the air, like a cloud trying to whisper a song only dogs and dreams can hear. You're probably not going to survive this entire episode without drifting off, by the way. It's just how the sky works. Soft mystery wrapped in air. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'd love to know where you're listening from and what time it is, so drop that in the comments if you like. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start by looking up. The clouds are ordinary enough. A loose patchwork drifting lazily above a sleeping town. But something's off. Not visual, not even emotional. Physical. A pressure, perhaps. A resonance. Like the world has a heartbeat you've only just begun to notice. Clouds, we're told, are passive, mute masses of water droplets obeying wind and condensation. But even the dullest school book admits clouds can rumble. Thunder is loud, yes, but it's not always lightning's companion. Sometimes there's no storm, no flash, just sound, subtle, rolling, felt in the ribs more than the ears. This is your starting point. The possibility that the sky is not silent. Mainstream meteorologists call it infrasound, frequencies below 20 hertz, beneath human hearing. Volcanoes make them, so do avalanches. And yes, clouds, especially towering cumulonimbus formations during periods of rapid growth. Think of them like breathing creatures, exhaling energy in waves. You recall an old weather report that mentioned atmospheric vibration anomalies near a sleepy lake in Finland. Locals thought it was tinnitus or ghost helicopters. But when researchers planted sensitive microphones, barometers in disguise, the clouds revealed their secret: deep, resonant pulses every 40 seconds, like breath, like chanting. So naturally, the next question is, why? Here's where science slips into the speculative. One theory posits that these frequencies are caused by minute changes in air density as clouds rise and fall. Another suggests the sound is born from wind shearing across layers of temperature difference, like rubbing your finger across a glass rim, but on a planetary scale. And then there's the fringe idea that clouds don't just make sound, they receive it. You pause. What does that even mean? Some physicists working at the edge of the respectable suggest clouds may act as natural resonators, like the wooden body of a violin. They could amplify deep frequencies emitted by other atmospheric processes. Gravity waves, solar wind interactions, even the rhythmic pulsing of Earth's crust as it subtly flexes under tidal forces. Yes, the moon tugs on land too, very, very slowly. You glance up again. That cloud above you, does it feel a little closer? You might laugh, but the atmosphere is a dynamic, restless entity. It's not surprising that clouds suspended in that ever-churning soup would be affected by forces we barely understand. Researchers still debate whether certain hums reported by humans are purely natural or if they involve electromagnetic components, frequencies that interact with our nervous systems. Not harmful, just detectable, subconsciously. Ever been creeped out in a completely empty room with no reason? It could be the air humming to itself. You remember an experiment from the 1990s, a physics lab in England that accidentally induced unease in test subjects by exposing them to an 18 hertz tone. The eerie part? The tone matched the resonant frequency of the human eyeball. People described feelings of dread and seeing gray shapes. So when the clouds hum and you feel a little strange, it's not necessarily in your head, or rather it is, but in a scientific way. Clouds could be interacting with the very architecture of your body. You smile softly. Maybe that's a comforting thought, that we're not separate from the sky, but tuned to it, resonant with it, like old radios waiting for the right wave. You lie back. The cloud passes over. The pressure shifts again. This is real. This hum, however faint, is part of our world. Always there, just beneath the reach of our hearing, waiting for sleepers and wanderers to notice. And tonight, you do. The cloud drifts on, but something lingers in its wake. A faint, bone-deep thrum. Not loud, not even audible, really. More like a suggestion, like the memory of music heard in a dream. You sit up slowly, following its trail across the sky. Your gaze lands on a darker cluster of clouds gathering on the horizon. Storm cells building themselves in secret. It's not raining, not yet, but there's something alive in their motion. Not the threat of thunder, but the feeling of something about to speak. And this is where things get stranger, because sometimes storms hum before they crack. There's a phenomenon observed in certain supercell formations, especially in the central plains of North America and parts of Australia, where local animals fall silent for minutes, even hours, before a storm arrives. Not because of pressure changes, not because of scent, but possibly because they hear something we don't. That sound, hypothetical though it may be, isn't thunder. It's subtler, deeper. It begins long before the clouds flash. Researchers call it pre-lightning infrasonics, a term that, admittedly, sounds like a low-budget sci-fi album, but the data's real. In 2014, an atmospheric study near Topeka, Kansas, set up infrasound sensors around a developing thunderstorm. Well before any lightning was visible, the sky emitted consistent pulses at zero point 0.7 hertz, almost 3 full minutes apart, like distant footsteps. And as the storm matured, those pulses changed in rhythm and shape, almost as if the cloud itself were pacing. You lie back again, imagining that, a cloud with a slow, deliberate heartbeat. Here's a quirky piece of research. In an isolated study conducted near Mount Fuji, a physicist recorded infrasonic bursts from convective clouds and matched them to the spherics, short bursts of electromagnetic radiation, registered on the same days. He theorized the clouds weren't just humming, they were broadcasting. Researchers still debate whether these spherics are random discharges or part of a broader electromagnetic dialogue between clouds and ground. Some go further, suggesting these frequencies help charge the storm, like the buildup of static before touching a doorknob. But instead of zapping your fingers, it electrifies the air. You grin at the image of a cumulonimbus nervously rubbing its sleeves together, waiting for a handshake. But back to the voice beneath the thunder. Why would a storm generate a consistent tone before it even sparks? One possibility lies in something called Kelvin-Helmholtz instability. Picture layers of air moving at different speeds, rubbing past one another, like shearing silk. These interactions don't just form the rare and beautiful wave clouds you sometimes see. They also create subtle pressure modulations. In the right conditions, they might generate extremely low-frequency sounds, rippling across the atmosphere long before the storm is born. You listen. The wind picks up slightly, and there's a deep flutter under it, like breath beneath fabric. Just like infrasound, this kind of flutter tends to pass through you more than around you. It moves the air in large, lazy rolls that your skin doesn't recognize, but your bones do. In fact, some researchers believe humans can feel infrasonic weather cues through our skeletal system, particularly the spine. Your back stiffens slightly at the idea, or maybe it's just the cool breeze. And it's not just humans. Elephants are known to detect infrasonic rumbles from distant thunderstorms up to 100 kilometers away, sometimes even predicting them before they appear on Doppler radar. They don't run, they pause. they listen. So what's stopping you? You lean your head back, eyes closed, and pretend your ribs are radio antennae. You don't hear anything, not really, but you feel something, a nudge, like a throat clearing. There's a reason some ancient cultures believed clouds were conscious, whispering gods, silent judges, or in some cases, divine messengers. The Greeks spoke of nephili, cloud nymphs that drifted between the world of men and the divine, carrying prayers, or sometimes warnings. You begin to wonder, were those old myths just poetic attempts to describe the indescribable? A way to account for a hum no one could name? Because whether it's weather or memory or something more peculiar, these sounds don't go unnoticed. You just have to be still enough, quiet enough, receptive enough. You take a deep breath, hold it. Above you, the storm cell rotates slightly, not dramatic, just enough to remind you that it's alive, that the sky moves not just through wind and water, but through rhythm. And maybe tonight, if you're lucky, it will share one with you. You don't move, you barely breathe, because something in you now wants to hear it, not just know about it, not just believe the science or entertain the mystery, but hear the inaudible. Feel the hum in its full shape, like a sound you somehow forgot how to perceive. Above, the storm cell has thickened. Not violent, just brooding, like it's lost in thought. This is the perfect moment to follow the frequency trail. Infrasound frequencies below 20 hertz is where this mystery lives. A deep, earth-hugging whisper that travels farther than any human voice, even farther than light in some cases, thanks to a peculiar quirk of physics. Long waves bend around mountains and hug the planet's curve. They don't get blocked, they wrap. So when a cloud produces infrasonic sound, that hum might circle the Earth multiple times. Imagine a tone so low and long it becomes a global lullaby, a sound that never truly disappears. It just loops, slowly fading into itself. You drift through that idea, slowly, softly. Mainstream science confirms that infrasonic signatures have been tracked from volcanic eruptions, massive storms, even ocean swells. But the clouds, especially towering dynamic ones, generate their own symphony. Thermal updrafts within them create pulsating pressure fronts. It's like shaking a massive velvet curtain in the wind. The sound is there, just not for ears. Fringe researchers call these cloud voices. It's not a formal term. You won't find it in any textbooks, but it's stuck around partly because it sounds too beautiful to replace. The idea is simple. When the right shape, moisture, and motion align, clouds begin to pulse, not randomly, but rhythmically. You smile, so even the sky has a kind of heartbeat. There's a theory, a strange one admittedly, that cloud-produced infrasound might subtly influence mood and behavior. Some experimental psychologists in the early 2000s tried exposing volunteers to 17 hertz tones, right on the edge of infrasonic range. The participants reported unease, sadness, or even mild hallucinations, though the ethics board probably started sweating before the volunteers did. Researchers still debate whether those emotional shifts were purely psychosomatic or if the human body actually registers subperceptual sound waves in measurable ways. After all, the human ear may not hear below 20 hertz, but the rest of your nervous system doesn't care about labels. You lie back on the ground now, and there it is again, a pressure, a tickle in the collarbone, a fuzziness behind your teeth. Maybe it's just the breeze. Maybe it's your body responding to the sky's long, low song. It's not just storms that sing either. Even the most benign clouds, fluffy, fair-weather cumulus, have been caught pulsing. A study from Belgium used microbarometers to record fluctuations as small as 0.001 atmospheres during rapid heating events in a summer field. The result? Regular pulses, not loud, not even continuous, but consistent enough to raise eyebrows. The lead scientist, who had a background in musical acoustics, noted that the pulse intervals aligned roughly with certain minor chords, something you'd expect from a cello, not the atmosphere. Coincidence? Maybe. But once you start seeing melody in the clouds, it's hard to unhear it. This brings you to a strange little corner of scientific history, the so-called sky tone project from the late 1970s. It was a private experiment conducted by an eccentric physicist in southern Italy who claimed he could play the clouds like instruments by projecting mirrored infrasound pulses back into them. He called it acoustic entrainment. His notes, scribbled in 5 languages, suggested that certain clouds would respond to specific tones by altering their shape or speed. The scientific community raised one collective eyebrow and quietly backed away. Still, some of his recordings were strange. A pair of balloon-mounted microphones captured a deep, warbling tone after a series of projected signals. The change in the cloud's motion was subtle, but measurable. It's never been replicated under peer review, but the data is archived somewhere in Naples. You imagine that man, standing on a hillside whispering to the clouds through speakers like a skybound DJ, trying to find the right note that makes the heavens shiver. Is it madness? Or just music no one else is quiet enough to hear? You stretch out, letting your limbs melt into the earth. There's no need to prove anything. The hum is either real or it isn't, but you feel it. The sky vibrates, slowly, deliberately, and you, whether by science or suggestion, begin to vibrate with it. You're floating now. Not literally, but in that way your body begins to dissolve when you've been still too long, perfectly still, under a sky that won't stop humming. The sensation isn't discomfort. It's more like soft static. A little like what you feel on an airplane when the engine noise fades into background texture. A mechanical lullaby. But this one doesn't come from machinery. It comes from clouds. And you begin to remember a strange paper, a footnote in a dusty journal you stumbled across once. It described an experiment conducted high in the Atacama Desert of northern Chile. On a forgotten mountain where the air is thin, the wind is sharp, and the clouds rarely linger. But when they do, they hum. The study, officially unnamed, was dubbed the Humming Mountain Experiment by the 3 graduate students who carried it out. Their supervisor, a semi-retired physicist with a fondness for old theories and older whiskey, had a hunch. He believed that under the right conditions, certain high-altitude clouds emitted tones measurable not just with barometers, but with finely tuned laser interferometers. You blink slowly. That's not a casual instrument. It's the same type of device used in gravitational wave detection, capable of noticing distance changes smaller than a proton's width. The fact that they brought one to a mountaintop in Chile tells you 2 things. They were either deeply dedicated or deeply bored. The fringe hypothesis that the clouds above the mountain weren't just producing infrasonic hums, but ones modulated by the terrain itself. The theory likened the mountain and sky to a duet, the rugged peaks and valleys forming an acoustic basin, while the clouds provided the vibrations. It wasn't sound in the traditional sense. It was pressure, subtle and rhythmically distinct. The experiment ran for 11 days. On day 3, just before dawn, their sensors picked up a pattern, waves pulsing at 1.2 hertz in 5-second intervals. Too deep to hear, too regular to dismiss. The clouds were barely visible, thin, wispy strata, but they clung to the peak like smoke curling from a sleeping beast. Then on day 5, the pulses shifted, 1.7 hertz, this time with a slight pitch bend. That's right, pitch. Not tone, not volume, pitch. You narrow your eyes. Even though there's nothing to see, pitch implies modulation, control, not random atmospheric burping, but something more coherent, like clouds that learned how to sing in a slightly different key. Researchers still debate whether this data set proves anything. The team's findings were never formally published. Some claim the fluctuations were from local microquakes or instrument drift. Others say a passing jet could have thrown off the readings. But here's the thing. The team returned 2 years later and tried again. This time, nothing. No pulses, no patterns. Just wind and silence. You sigh gently. Maybe that's how sky mysteries work. Like shy animals. They appear when you're not trying to see them. You imagine standing at the peak of that mountain, thin air biting your cheeks, eyes closed against the cold. You hold your breath, and in that moment, feel something pass through you. Not wind, not sound, just presence. There's a beautiful idea, floated by acoustic ecologists, that every landscape has a baseline resonance, a low-frequency signature born from its geography, its weather, its history. Mountains murmur, valleys sigh, and clouds, those ephemeral drifters, act like tuning forks suspended in the mix, resonating with the land below. It makes you wonder, if every region has a baseline song, what's yours? You lie still, letting that question sink. The idea that the sky might not be humming at you, but with you. And perhaps, just perhaps, that little shift in pitch on the mountain wasn't random at all. Maybe the clouds were adjusting. Maybe they were listening too. The clouds above you stretch thin, like worn silk pulled across the sky's vast drumhead. There's no storm here, no urgency, just distance and vibration. You find yourself wondering what lies above all this, above the troposphere, past the playful swirls and grumpy storm heads, up where the air forgets how to carry weather. Does the hum reach that far? You rise in your mind, drifting beyond the highest cumulonimbus, past the thin streaks of cirrus, through the tropopause, where clouds begin to forget their name, and you arrive at the edge of space. Welcome to the stratosphere. It's colder here, dry, crisp, and eerily still. A realm of silence, if you believe your ears. But listen with something deeper, your imagination, your bones, and you begin to catch echoes. They're called sprites. You've probably never seen one. Most people haven't. Sprites are brief, ghostly flashes of red light that leap upward from the tops of thunderstorms into the mesosphere. Blink, and they're gone. But when they appear, they move like jellyfish, graceful, bioluminescent, and in a way, musical. No, not because they make sound in the traditional sense. They're electrical discharges, too quick to produce audible noise. But some atmospheric physicists argue that sprites and their cousins, blue jets and elves, create ultra-low frequency waves as they dance. Vibrations, ripples, ghost tones. In 2001, a research balloon drifting over South America recorded brief fluctuations in the air pressure at altitudes where no weather should occur. The culprit? Sprites. Each pressure dip corresponded with high-speed footage of the light burst, suggesting these ephemeral flashes might punch the sky, sending tremors downward. You picture it, a flash above a storm, and moments later, a low, low tone vibrating through the clouds like a sigh from the stars. Researchers still debate whether these waves are truly linked to sprites or if the balloon sensors were simply shivering from thermal change. But the notion persists that the upper atmosphere is not just alive, but expressive. Here's a quirky fact. During certain solar storms, the Earth's ionosphere, the charged shell high above the clouds, shrinks inward. When this happens, it brushes closer to the stratosphere, and strange things start to happen. Radio signals stretch. Magnetic fields flicker, and clouds, especially at twilight, begin to shimmer at odd angles. A team in Norway once reported a chorus of infrasonic pulses, brief and melodic, during one such event. They called it skyquakes. Nothing boomed, no jets, just pulses of soundless sound recorded across multiple elevations. Some patterns repeated every 92 seconds, the same frequency as the orbital period of certain low Earth satellites. Coincidence? Possibly, but it makes you think. What if some of these frequencies aren't born in the clouds, but transmitted through them? You consider the idea of clouds as conduits, not just generators of sound, but passengers of it, drifting amplifiers for forces far above. The ionosphere, solar winds, even faint geomagnetic harmonics. You chuckle softly, not because it's ridiculous, but because you've spent your whole life looking down when listening. Now it seems the real music is above you. You float back down through the upper air. The ozone brushes past you like glassy frost. And there, between the layers, something pulses again. Just a blip, a shift in pressure. You can't hear it, but you feel it, right behind your ears. When you settle once more beneath the clouds, the sky looks the same, unmoved. But you're not the same. Now you know something. The clouds aren't just humming for themselves. They might be carrying whispers from the edge of space. You open your eyes to a memory. It's late summer, the kind that's sticky with heat and long with golden light. You're walking a back road in the countryside, the hum of cicadas pressing against your ears like static from a warm radio. But you're not listening to them. Not really. You're watching the sky. There's a single cloud up there. Small, puffball shaped. Looks like it belongs in a picture book. But the strange thing is, it's been following you. Not quickly, not with purpose. Just drifting where you drift, as if tethered to some part of you your body can't locate. You pause, it pauses, you walk, it resumes. The rational part of you laughs. Of course it's coincidence. Winds, thermals, perspective. But the irrational part, the part that sometimes dreams in weather, that part wonders. And then that same old hum again, faint, almost like an exhale through cotton. You lie down on the side of the road, grass tickling your skin, dust clinging to your elbow. You stare at the cloud. Is it humming? Mainstream meteorology explains away clouds like that with the concept of persistent convection, a warm air pocket rising steadily in one spot, generating a cloud that stays mostly in place even as the ground moves beneath it. You're simply walking into its shadow again and again, but some days it feels like more than coincidence. A group of researchers in New Zealand once tracked stubborn clouds, formations that didn't move according to the surrounding wind data. They lingered, hovered, or shifted against predicted trajectories. The scientists theorized these clouds formed around rare thermal anomalies, small pockets of rising air insulated by humidity, like hot air balloons in reverse. But even they admitted some clouds behaved weirdly. You return to that memory of the walking cloud, and this time, imagine something else. What if it knew? Not in a sentient Pixar movie kind of way, but in the way mushrooms know when to fruit, or how flowers turn their faces. What if clouds, composed of thousands of micro droplets, each charged, each responsive to pressure, light, and vibration, had a kind of emergent awareness? Fringe? Sure, but not impossible. A theoretical physicist once proposed that atmospheric systems, especially complex cloud masses, might exhibit what he called reactive coherence, a temporary localized intelligence formed by feedback loops between moisture, light, and sound. Researchers still debate whether this counts as cognition. Is it thought if it doesn't think about anything? Or is it just atmospheric jazz? But back in your memory, lying by the road, something shifted. The cloud above you let out one more of those long, low pulses. You didn't hear it. You felt it. In your sternum. Like when someone speaks to you through a wall, a feeling more than a sound. And then, only then, it finally drifted away. You stayed there a long time, unsure what had happened. You knew the science. You also knew the feeling that a cloud had followed you, watched you, and then, when it had finished whatever it was doing, let you go. Now lying beneath another sky, years later, you feel the same sensation, a hovering, a silent note being held above your body. And you wonder, do some clouds pick favorites? The sensation lingers, a gentle, persistent pressure along your collarbones, like someone softly humming through your skin. The clouds above haven't moved much, but you have, not in body, but in perception. What began as idle curiosity has started to feel familiar. You wonder if your body always noticed the sky's hum, only now your mind has decided to join in. This is where the path bends toward the lost, toward the frequencies no one hears anymore. You stretch out your arms as if to catch the sound with your fingertips. What if the sky used to be louder? Or maybe, what if we used to be quieter? There's an entire theory floating around in the misty borderlands of atmospheric physics called sky resonance. The idea that the Earth's atmosphere vibrates at naturally occurring ultra-low frequencies like a massive musical instrument. These aren't caused by anything external. They're built into the shape of our planet, our atmosphere's thickness, the speed of light and sound across it all. One of these resonant frequencies is about 7.83 hertz. It's called the Schumann resonance, and it pulses constantly around us, formed by lightning strikes trapped between the Earth and the ionosphere. Some call it Earth's heartbeat. Others say it's our global metronome. The interesting bit? That frequency just happens to fall within the natural range of brainwave activity known as theta waves, the ones tied to daydreaming, deep meditation, and the space between wakefulness and sleep. Researchers still debate whether Schumann resonances influence human consciousness directly, but those who've studied long-term meditation practices claim practitioners often synchronize with those rhythms naturally, without knowing the science at all, which raises a quiet, wild idea. What if part of us remembers the frequency of the sky? You shift on the ground slightly, the air settling heavier against your chest. This next piece is stranger, older. There's a scroll held in a small museum in the Japanese countryside that includes an ancient weather record written by a sky watcher named Kenjiro. In one passage, he describes the return of the cloud singers, a seasonal phenomenon where clouds appeared at the same time each year, over the same hills, and murmured low sounds like wind inside a drum. His writings were dismissed as poetic metaphor. But then, centuries later, weather sensors set up near the same location picked up infrasonic pulses at intervals matching Kenjiro's notes. Not a perfect match, no, but close enough to raise an eyebrow. Or two. No one's been able to explain the modern readings. There's no military base nearby, no volcano, no air traffic, just hills and clouds, singing. You start to suspect something. Maybe the loss isn't that the sky stopped singing. Maybe the loss is that we stopped listening. Back in the early 1900s, a French climatologist named Émile Marchot built what he called a sky organ, an instrument composed entirely of barometric tubes and tension wires strung between tall masts. When the wind shifted just right, the wires would resonate. He claimed the clouds tuned the instrument with their presence. He played it once for a gathering of skeptics. No music, just a single tone, low, slow, almost imperceptible. Most laughed, but one old physicist said it made his bones feel warm, not his ears. His bones. That organ is now dismantled, the pieces rusting in a barn. But the idea remains that perhaps the sky has always played a symphony, and every now and then we catch a note. You turn your head toward a tall bank of clouds rising in the distance, silent, stately. Their movement is almost imperceptible, but you imagine them vibrating, trembling with old harmonics that stretch beyond your hearing. And if you close your eyes, you might hear them too, not through your ears, but through the parts of you that remember how to hum. The clouds thicken now, stacking gently like layers of pale slate. You don't flinch. Their approach is slow, unthreatening, majestic in the way mountains sometimes seem to move when you aren't looking. There's a warmth in the air, not from the sun, but from motion, like the sky's breath settling into a rhythm. And then it comes, a different hum. This one isn't subtle. It's not heard, not even felt through your skin like the others. It's within. A vibration that doesn't belong to the ground or the wind. It spirals like a distant drum roll, but stretched across minutes instead of seconds. You're entering the realm of the spiral storm. Tornadoes have a reputation for chaos, thrashing winds, abrupt movement, destruction. But what's often overlooked, or maybe ignored, is how structured they are. Organized, almost elegant in their mathematics. They sing. You heard that right. Tornadoes emit infrasonic frequencies as they form and spin well before they touch ground. These aren't the loud roar of a funnel. They're deep, droning tones that spiral from the rotating column of air like a didgeridoo 3 miles tall. In 2003, a group of researchers using high-sensitivity microbarometers in Oklahoma detected infrasonic emissions from a tornado up to 30 minutes before visual confirmation. The tone? Roughly zero point 0.5 hertz, low enough to be felt rather than heard, a frequency that flutters right at the threshold of perception. But here's the odd part. As the tornado grew, the pitch changed. Not randomly, but musically. The tones rose in predictable intervals, like scales. One scientist likened it to a slow, breathless arpeggio played by the sky. Researchers still debate whether this phenomenon is a structural byproduct, air spiraling at different speeds causing pressure oscillations, or if there's something more coordinated at work, perhaps even something we haven't yet understood about atmospheric resonance. There's a fringe theory, a weird one even by weird standards, that these storms act like natural oscillators, that they don't just hum incidentally, but require the hum to form. The theory comes from an experimental physicist turned storm chaser who built a mobile infrasonic lab inside a weatherproofed RV. He believed that beneath a certain frequency threshold, the Earth's atmosphere enters a kind of resonance chamber. When wind, heat, and terrain align just right, that chamber rings like a bell, and sometimes that bell rings itself into a tornado. You roll the idea around in your mind like a marble. What if the storm isn't just a result of weather, but a side effect of sound? You're still lying under the sky, but now your heartbeat has synced to the rhythm of the air. You imagine being in the eye of one of those slow giants, not the roaring wall of dust and debris, but the calm interior, the quiet cylinder where nothing moves. It's said that time stretches in that space, that everything goes soft. Some storm chasers report hearing strange sounds in that stillness. Not just silence, but resonance, like being inside a cello. Others speak of harmonics, a layering of barely audible tones that tickle the teeth and tighten the spine. You smile. It's a familiar feeling by now. In 2010, an amateur meteorologist near Lubbock, Texas, recorded a spiral-shaped pressure pattern during a small, short-lived tornado. He plotted the frequencies and, on a whim, transcribed them into musical notation. It resembled a minor chord. Coincidence? Perhaps. But maybe, just maybe, tornadoes don't roar. They chant. You think about that as the sky above you darkens just a touch. No storm is coming, not tonight, but you can feel a kind of rotation in the air, a pressure gradient, like a thought preparing to form. The hum here is long and low, curving gently around your head. It doesn't frighten you, not anymore. Because now you understand. There are spirals in the wind, and they carry songs made from forces older than language. And when those spirals align just right, they become music. The air has shifted again. Lighter now, thinner, like fabric stretched taut just before it tears. But it doesn't. It holds. The clouds above you are still, suspended like thoughts you haven't finished thinking. Tonight, the hum comes from higher up, not the clouds themselves, not the ground. Something in between. You're following a trail now, one mapped not by stars or footprints, but by balloons. Not the party kind, though you do smile imagining a weather scientist tying a helium tank to a birthday balloon. No, these are high-altitude balloons. Big, strong, able to reach the edge of space. But what they carry is delicate. Microphones, specifically designed to listen to the sky. This idea of using balloons to eavesdrop on atmospheric sound has been around since the Cold War, when militaries tried to detect nuclear tests from halfway around the world. But in recent years, scientists have reimagined those tools, not to listen for weapons, to listen for weather, and the results are eerie. One research team, led by a quietly eccentric acoustician in New Mexico, launched a fleet of these balloons into a storm system rolling off the Gulf of Mexico. Each balloon carried barometric microphones sensitive to pressure changes smaller than a feather's weight. The data returned didn't just confirm cloud-generated infrasound. It revealed patterns, tones, pulses, rhythmic sequences that seemed to track the shape of the storm. One balloon floated directly above a cumulonimbus cluster for 4 hours. During that time, its sensors recorded pulses every 21 seconds, shifting subtly in frequency as the cloud rose. The changes weren't random. They formed a curve, rising, falling, stabilizing, like a song learning to sing itself. Researchers still debate whether these readings came from the clouds alone or from the interaction between storm and stratosphere. Some believe the balloons were picking up echoes from the jet stream, reverberations bouncing downward, carried by thermal layers like sound waves through canyon walls. There's something poetic in the idea that these balloons weren't just recording sound, they were surfing it. And here's where it gets quirky. One balloon launched over the Mojave Desert drifted into a region of totally clear skies. No clouds, no wind, nothing but dry silence, and yet it recorded a tone, a single, stable frequency of 9.3 hertz, sustained for nearly 3 hours. No storms nearby, no planes, no tectonic activity, just sky. The team named it the Whisper, and to this day, no one knows what caused it. They theorized upper-level wave resonance, gravity waves colliding and amplifying like ripples in a bathtub. But the frequency was oddly specific, almost tuned. Some suggested it was an echo from a previous storm, still reverberating across thermal layers. Others proposed an experimental aircraft, or, of course, aliens, but the sensors were clear, the data clean, no interference, just a single persistent hum that refused to fade. That balloon floated for 27 hours before landing softly in a Joshua tree grove, its microphones still ticking away like a metronome with no conductor. You think about that balloon, weightless, wandering, listening to a sky that most of us never even think has a voice. You wonder if, had you been floating beside it, you might have felt the hum in your teeth or in your dreams. The beauty of balloons is their simplicity. They don't thrust, they don't steer, they don't demand. They rise, they drift, they receive. And maybe that's the key to hearing the sky, not forcing it to speak, but giving it the space to be heard. You close your eyes again and imagine being tethered to nothing, carried by thermals, brushing the bellies of clouds that sing in frequencies you'll never name. Not everything must be understood. Some things, like whispers at the edge of sleep, are meant only to be noticed and then released. You're somewhere between awake and not, your body heavy in the grass, your breath matching the rhythm of the wind. The clouds are more than shapes now. They're companions, passers-by, gentle musicians in an orchestra no one's leading. Above you, a small mist bank glides by low, slow, quiet, and suddenly, without knowing why, you think of monks, not the chanting kind, though that would fit, but the watching kind, the ones who listen to the sky and the sea, recording what they heard with careful brushstrokes or whispered memory, the ones who knew silence was never really silent. And in the hush of that thought, a peculiar memory surfaces, a story you once heard, or dreamed, or both. A monk in 13th century Ireland wrote of singing clouds. He claimed they came every spring, drifting in from the sea, making no sound, yet leaving behind the sense of having heard something beautiful. He described it as the memory of music on a still day. Centuries later, a shepherd in the Pyrenees described something similar. Low fog rolling down the valley, wrapping his flock in silence, and then a sensation, a gentle vibration behind his eyes like someone humming at the edge of thought. His dog heard it too, ears perked, body still, but no barking. It was as if the cloud was singing, but not for the ears. You smile at the absurdity and at the possibility. These anecdotes were long dismissed as weathered folklore, stories from people who'd spent too much time alone. But in the last few decades, atmospheric acousticians began to take a second look. Why? Because the phenomenon kept coming up. Accounts of clouds that left no sound on tape, but induced the sensation of sound in those who stood beneath them. Some call it silent resonance. Others, more playfully, refer to it as the mirage of musical clouds. Mainstream science has no formal explanation. There are speculations, though. One theory suggests that certain cloud conditions, especially within fog banks or stratus layers close to the ground, can create standing waves of air pressure. These waves don't make traditional noise, but they can disturb the tiny hairs in your ear canal. The result? A feeling of sound with no origin. Another quirkier idea involves temperature gradients. The difference between the warmth of your body and the cool breath of a low-lying cloud can create localized pressure differences across your skull. This in turn may stimulate your auditory nerves, not enough to hear an actual tone, but enough to feel like you almost did. And researchers still debate whether these experiences are purely physiological or if they're something more complex. Some acoustic engineers have found that low-frequency air modulations can induce neurological crossovers, where the brain misinterprets subtle physical stimuli as sound. Like phantom harmonies echoing through the nervous system, you've probably experienced something similar in a dream. That moment when you think you hear a lullaby, but there's no instrument, no voice, just a tune forming itself from nothing. That's what these clouds seem to do. You let your mind drift now into the idea of perception itself. Do we hear with our ears or with our attention? It makes you wonder how many things we miss because we've decided not to believe they exist. Just above the valley floor, a fog curtain is forming, thin, wandering, harmless, and yet your skin prickles, not in fear but in recognition. The temperature drops by a whisper. The soundscape changes, not with noise but with absence. And in that absence, you almost hear something. Not a melody, not a chord, just a presence, a pressure. A reminder that sound doesn't need to be loud to be real. Somewhere nearby, a cricket stops chirping. You smile, because maybe, just maybe, the cloud is singing again. And tonight, you remembered how to listen. The fog has settled now, but not in a suffocating way. It curls softly around your shoulders, a scarf of vapor, almost affectionate. The air is quieter than it should be. No distant traffic, no rustling leaves, just you and a softness so complete it borders on surreal. And then you remember the hum. Not this hum, though, a different one, the one with a capital H. The hum. You've probably heard of it. Stories whispered across forums and midnight radio shows. People in cities, towns, even remote countrysides reporting an elusive, low-frequency droning sound that never quite goes away. Often at night, often alone, a sound that haunts rather than sings. Some describe it like an idling truck in the distance. Others say it feels like the earth is quietly moaning through a floorboard. In Taos, New Mexico, it's so notorious they named it. In Bristol, England, locals created a task force to investigate. From Auckland to Ontario to tiny villages in Scotland, the story repeats. The hum is there, and it won't shut up, except there's nothing to record. Microphones often pick up nothing, and when they do, it's inconsistent. The frequency hovers between 30 to 80 hertz, low, deep, a kind of somber growl. But not always, not reliably, and not for everyone. Roughly 2% of the population hears it. You wonder why. Researchers still debate whether the hum is environmental, biological, or psychological. Is it an undiscovered form of pollution? Some new byproduct of industrial life? Or could it be something within us, like spontaneous otoacoustic emissions from our own ears? A self-generated tone with no external source? It's possible, but then, why do some people hear it in the wilderness? You think back to the fog, the feeling, that pressure against the bones behind your ears. Could that be the same thing, tuned differently? A natural hum that overlaps with the hum? Or is the hum itself an atmospheric phenomenon no one's properly mapped yet? There was one study. You remember it because it was so delightfully peculiar. A Canadian physicist theorized that the hum might be the result of atmospheric ducting, low-frequency sound waves bouncing between temperature layers in the sky and the Earth's surface, forming a kind of sonic tunnel. These trapped frequencies, he proposed, could resonate with certain buildings, bodies, even skulls. He spent a year listening to caves. That's not a metaphor. He set up instruments in cave networks, trying to match infrasound pulses to local weather conditions and reported hum complaints. His results? Inconclusive, but fascinating. He found that during inversions, when warm air sits above cold, the caves did vibrate more. And in those moments, some locals living above ground claimed the hum was louder. It's a strange comfort, really, that something so eerie might have such a humble origin, a trapped sky song bouncing between invisible layers. Still, the question persists. Why do some people hear it and others don't? There's a fringe idea that the hum isn't a single thing at all, but an overlapping series of frequencies, both natural and artificial. Radio towers, fault lines, ocean currents, atmospheric tides. Combined, they create a kind of planet-wide harmonic soup. Most of us tune it out. A few of us tune in. You roll onto your side, pressing your cheek to the earth. The ground is warm here, strangely so. And suddenly you realize you're humming, not aloud, not on purpose, but your vocal cords are vibrating, faintly, subconsciously, matching something above you, or maybe beneath. You aren't sure anymore. The hum is everywhere now, or maybe it always was. You just finally started singing back. The night feels deeper now, like it's folded over itself. You're not just lying beneath the sky, you're nestled within it. The clouds no longer float above you. They hover with you, as if you and they are sharing the same altitude, the same thought. And the hum continues, but now something strange stirs in its rhythm. A tone that doesn't feel like it belongs to air. It's rounder, smoother, wet. It sounds like whale song. You chuckle because that's ridiculous. You're not underwater. You're not even near the ocean. And yet the pattern is unmistakable. That long, slow warble. the rising, aching pulse, a sound that wants to be both music and memory. Clouds don't sound like whales, you tell yourself. But then again, maybe whales don't sound like whales either. Maybe they sound like the sky. Here's where things get strange. Stranger. A team of polar researchers stationed on the edge of Antarctica once reported unusual recordings, low frequency, harmonic pulses occurring in sync with weather fronts moving across the ice shelf. They weren't seismic, they weren't man-made. And when they were sonified, translated into audible tones, they resembled vocal patterns. More specifically, marine mammal vocalizations. Now, were they actually whales? Of course not. These sounds came from the sky, not the sea. But they mimic the shape of whale song. Frequency glides, repeating cycles, long, low moans that crescendo and fade like breath through a conch shell. One researcher joked they discovered sky cetaceans, imaginary beasts made of moisture and tone. But beneath the humor, the data remained. Why would cloud systems echo marine frequencies? One possibility lies in harmonic convergence, a phenomenon where different natural systems independently evolve similar resonant patterns because they are shaped by the same physics. Think of a cello and a seashell. They resonate differently, but both are governed by vibration and shape. Clouds, like water, are fluid. They move in waves, and when air masses compress and stretch across thermal gradients, they create tonal sweeps that mirror acoustic curves found in oceans, especially under extreme conditions, like polar storms or equatorial convergence zones. You imagine it now, massive cloud banks rolling over icy fjords, releasing infrasonic pulses that coil through the sky like the songs of ancient whales lost at altitude. Researchers still debate whether this effect is coincidence or evidence of some deeper acoustic architecture built into our world. But even skeptics admit the tonal similarities are uncanny. There's also the theory, rarely discussed in polite science, that whales and clouds may respond to similar cues. Solar cycles, for instance, modulate Earth's magnetosphere, which affects both high-altitude cloud behavior and certain migratory patterns of marine mammals. It's speculative, but some believe these pulses, these low, slow beats, could be universal rhythm markers, clocks older than civilization, heard only by those who move with the planet. And maybe tonight, that includes you. You let your chest rise and fall with the imagined breath of the sky. Not shallow, not forced, deep, oceanic. Your lungs fill with night air that feels almost liquid. You wonder if this is what it's like to drift through both sky and sea at once, to float in a place where clouds echo sonar and the stars above blink like bioluminescent creatures. For a brief moment, you consider letting go completely, just dissolving into the rhythm, humming your name into the atmosphere and seeing what echoes back. And perhaps somewhere in that silence between tones, the sky will recognize your frequency and hum it back to you. The hum has changed again, subtly like a dream shifting tone between scenes. You feel it before you notice it, your breath aligning to a new rhythm, your thoughts smoothing out like a path just swept clean. This hum doesn't spiral, it flows. You're not under a storm or near the sea now. You're above it all, sailing in the great aerial river called the jet stream. You've never really seen it, of course. Few have. But you felt its presence on transcontinental flights that arrive suspiciously early or during weather forecasts where storms seem to leap across half a continent in a day. The jet stream is fast, high, and loud in a way our ears aren't built to perceive. But our bodies, they listen anyway. The jet stream is a band of roaring air, thousands of kilometers long, hundreds wide, and just a few kilometers thick, moving at speeds up to 250 miles per hour. It races through the upper levels of the troposphere, the atmosphere's most chaotic and musical layer. It sings, not with the voice of thunderclouds or whispering fog. No, the jet stream hums with an eerie steadiness, its vibrations carried in the pressure waves it leaves in its wake. These oscillations, though too low for us to hear, are constant, repetitive, almost metronomic. One project, run by an interdisciplinary team of climatologists and composers, recorded infrasonic data from the jet stream for 6 months, converting it into audible frequencies. What emerged was a strange kind of symphony, overlapping pulses, slow fades, rising scales. A melody built from air itself. They called it the unfinished symphony of the jet stream. Researchers still debate whether these patterns are just artifacts of instrumentation or if the jet stream actually emits a kind of structured signal shaped by mountains, storms, and the Earth's own rotation. A fringe acoustics researcher once proposed that these tones may influence lower atmospheric behavior, guiding or suppressing cloud formation like a conductor gestures to silence or crescendo. She believed that when the jet stream hums just right, it invites certain types of clouds to rise and others to dissipate. Most dismissed her theory, but she recorded dozens of instances where specific infrasonic shifts preceded major atmospheric events. Cold fronts collapsing unexpectedly, storms stalling over open water, clouds breaking into hexagonal patterns without known cause. Her instruments may not have proven causality, but her recordings were beautiful. You listen now, not with curiosity, but with calm. The sky above you feels higher than usual, as if the clouds have stepped aside to give the jet stream room to sing. The hum is steadier here, less like breath, more like pulse. There's a pressure on your sternum, not uncomfortable, just present, like someone resting a warm hand over your heart. And beneath that, a tickle of vibration, a faint rolling beat, as if the wind, impossibly fast and impossibly far away, has wrapped its long arms around the entire sky and begun to drum. You stretch your fingers and wonder if this beat has always been with you, since birth, since before memory. A sonic umbilical cord connecting you to motion, time, air, and maybe to the clouds themselves. Because in this place, above place, where wind sings and sky listens, the clouds aren't separate passengers. They're dancers, partners, moving in slow, dreamlike gestures across the jet stream's invisible stage. You imagine them twirling gently, vaporous gowns trailing behind, spinning in time with a rhythm you're just beginning to understand. You're not just a listener anymore. You're part of the song. You're drifting now, weightless in thought and body, carried on the memory of sound. The jet stream's pulse still echoes faintly behind your ribs, but the rhythm has softened, slowed. You descend, not in a fall, but like a feather, toward a place you'd almost forgotten. An old hill rises ahead, modest, quiet, carpeted in lichen and low stones. At its summit, a ruin. Low walls, sun-bleached columns, and the skeleton of a dome, half buried, half reclaimed by time. This is the site. You recognize it without knowing how. An ancient observatory, long since forgotten by maps, but not by the sky. You approach slowly. The wind stills. The clouds, those familiar companions, have gathered directly overhead. A heavy one lingers above the dome, completely still. Not moving with the wind, not melting, just hovering, as if held by invisible strings. You feel it before you hear it. A silence so complete it has weight, texture, the kind of hush that comes not from absence, but attention. The cloud is listening, you step beneath it, and the pressure changes. The sensation is sudden but gentle, like walking into a warm, thick current underwater. The hairs on your arms rise. Your breath catches just for a moment. Something here is tuned. Mainstream historians know of dozens of ancient sky-watching sites. Stonehenge, Chankillo, the 13 Towers of Peru. But there are others, unmapped, unclaimed. Small observatories built not to chart planets or predict seasons, but to hear. In northern Anatolia, an unexcavated shrine contains a ring of smooth stone with boreholes aligned not to stars, but to sound corridors designed to channel wind. Researchers once set up infrasonic microphones there and captured pressure pulses every 46 seconds, matching the harmonic signature of distant thunder hundreds of miles away. The site you found now may be similar. No instruments remain, no inscriptions, but the way the stones are shaped, the way the dome curves, it feels deliberate, a place built to cradle the sky's quietest voices. And tonight, the sky is speaking. The cloud above hasn't moved. You lie down inside the ruin's center. The stones are warm, not from the sun, but from time. Your head rests against one, and immediately you feel a gentle vibration, like a cat purring against the bones of the earth. Researchers still debate whether ancient cultures had the means to detect infrasound. No written records describe it, but carvings show spirals, nested waves, and concentric arcs that some believe depict pressure patterns, not just artistic flourishes. A few fringe archaeologists have proposed that sites like this one were resonance chambers designed not for ritual, but for reception, that people didn't pray in these ruins. They listened to clouds, to storms, to the low, endless hum of the turning planet. You close your eyes and tune in, not with effort, with permission. The still cloud above you begins to pulse, not in light or color, but in presence. Every few seconds you feel a shift, a breath, a heartbeat that isn't yours. It doesn't speak. It doesn't need to. It just is. And in that moment, so are you. No questions, no answers, just the long, slow song of a cloud that remembers how to wait. The cloud hasn't moved. You've lost all sense of time. It might have been minutes, or hours, or one long inhalation that never needed to end. Around you, the stones are beginning to cool, not in temperature, but in tone. Whatever silent resonance once flowed through the ruins is softening now, retreating into the earth like a tide of air returning to the sea. The cloud overhead doesn't disappear. It dissolves, not into rain, not into wind, just into less. And suddenly the sky is still. Not silent, not empty, just quiet. The kind of quiet that settles into the corners of old rooms. The kind that trails behind the last page of a well-loved book. The quiet that lingers after something important has ended, but gently. You rise slowly, your limbs heavier now, as though you've been underwater and gravity has remembered its job. Something has changed. There's no more hum, not from the ground, not from above. Not even that subtle, spine-tingling frequency that once sat behind your ears like a whisper waiting its turn. The sky has gone still, and it feels okay. You begin to descend the hill, leaving the observatory behind. No fanfare, no sudden gust of wind, just the soft crunch of your feet on soil. The air tastes clean, balanced. Below, the land is sleeping. The horizon is wrapped in a blue so deep, it no longer feels like color, it feels like distance. You wonder, was the sky ever humming at all? Maybe, maybe not. But what's more important now is that your body still remembers the rhythm. Even with the silence wrapped around you, your breath moves like music. Your steps fall into cadence with memory. And your mind carries the echoes of tones you never truly heard, but felt. Researchers still debate whether clouds are truly capable of infrasonic song, whether the sky hides a symphony of pulses and frequencies too subtle for science to catch. And honestly, let them debate. That's their work. Your work tonight was only to notice. And you did. The clouds may not hum forever. The storms may quiet. The jet stream may shift. But you were here, and you listened. And now, as the sky falls into its final hush, you do too. Wind down. Let your eyes soften now, if they haven't already. The night has folded itself around you like a worn, familiar blanket. The clouds, those steady companions, have retreated, not in loss, but in rest. Nothing hums anymore. Nothing needs to. You've walked among invisible waves, spirals of sound, ancient ruins that never needed names. You've drifted in tune with storms and silence alike. You felt pressure without weight, music without melody, voices that never required words. And now it's quiet. Let your thoughts follow the clouds, slow, unhurried, dissolving at their edges. Let the rhythm fade from your body until only stillness remains. Let the earth carry your breath. Let the sky carry your sleep. Let everything hum, no more. Thank you for watching and listening. Don't forget to like and subscribe to keep exploring more mysteries in our next videos.